Now today we are going to study types of growth. See, growth, you know what is growth. Again, in one sentence I'll tell you what is growth. Growth is nothing but it is a permanent and irreversible increase in an organism. Once the growth had taken place, it never comes down or it never becomes reverse. It is always permanent. So now today we are going to study in our topic types of growth. See, there are two types of growth. One growth is called as arithmetic growth. First type of growth is arithmetic growth and another one is geometric growth. Okay, AG, arithmetic growth and geometric growth. First of all, I'll explain you what is the meaning of arithmetic growth. See, for explaining this, I'll consider one example. Okay, suppose I have taken one cell. We are considering one meristematic cell. This meristematic cell when undergo mitosis. Mitosis means from one cell, two cells are formed. Okay, it is clear from the diagram. When this meristematic cell undergo mitosis, it forms two cells. Okay, out of these two cells, one cell becomes differentiated or it becomes mature. Means this cell afterward is not going to divide. It becomes matured or differentiated means it becomes either xylem, phloem, parenchyma, chlorenchyma, erenchyma. It may be anything. Okay, and it starts doing its own function other than except cell division. Okay, so out of these two cells, one becomes differentiated or maturated and one cell remains meristematic. Means this cell is going to divide. Okay, again what happens? This meristematic cell again undergo mitosis and it forms two cells. Okay, now again out of these two cells, one cell becomes differentiated or maturated. Means it is now these two cells are not going to divide. Only one cell regains the capacity or have the capacity to divide or redivide. So again this cell only divide into two daughter cell. Now from this two daughter cell again one become differentiated. Okay, means what is happening over here? Here single cell when give rise to two daughter cell, one every time is getting differentiated and only one cell is getting divided. Okay, so here the growth is taking place. It is continuously the growth is taking place, but it is at slower rate. I can explain you this arithmetic growth with the help of graph. If the graph is plotted, means see what happens if suppose this much growth had taken place in a particular period of time. Okay, if suppose this much growth had taken place in a particular period of time. If this much growth had taken place in a particular period of time, what happens when you plot a graph? You will get linear graph. Okay, you will get linear graph. Okay. Now what happens? This arithmetic growth can be calculated with the help of one formula. This formula is LT is equal to L0 plus RT, where LT means length after time t. This is the length, total length after a particular time, after a time interval. So this is LT means the total length after a particular period of time. L0 means this growth. Initial growth at the initial stage or length at the initial stage. This is L0. R means rate of growth. How much growth had taken place. And T means time of growth, means how much time is required for the growth to take place. So here we have completed arithmetic growth. In short, I'll tell you first arithmetic growth I have explained you with the help of example, with the help of graph and with the help of formula. What happens here when single cell divides into two cell means mitosis takes place. One cell, every time one cell becomes differentiated and only one cell divides and redivides. Okay, when we plot a graph for this arithmetic growth, we will get linear graph. Okay, this graph or this growth, arithmetic growth can be calculated with the help of one formula. This formula is LT is equal to L0 plus RT. Okay, so here we have completed arithmetic growth. Now we'll move towards geometric growth. Same I'll explain you with the help of example, graph and formula. See now here we'll consider one cell, meristematic cell. Meristematic cell undergo mitosis, means it produces two cells. Now what happens? What is the difference between two? Here when the cell gives rise to two cells, one cell every time is getting differentiated. But it is not the case here. Here when the meristematic cell gives rise to two daughter cell, they remains as meristematic. They regain the, or they have the capacity to divide and redivide. So every time each and every cell is undergoing mitosis, and from one cell every time two cells are formed. Okay, now here if you see, the growth is very fast from 1 cell to 2 to 4, 4 to 8, 8 to 16, 16 to 32, 32 to 64. Like this way, in this way, very fast the growth or the division is taking place. Okay, when we plot the graph for this geometric growth, okay, when we plot the graph for this geometric growth, we get the S-shaped curve. This type of curve we get. While here we will get the linear growth because the growth is continuous, slow but continuous. But here what happens? We get S-shaped curve. This S stands for sigmoid growth curve we will get. Now what it means? It means, this means actually what happens here at the starting. You can see from here also. At the starting, very less growth is taking place. Okay, only this much growth is taking place, but the time required is maximum. So this phase is called as lag phase. Here growth is taking place, but too much time is required, and in too much time very little growth is taking place. Okay, later on what happened? See, from 2 to 4, from 4 directly 16 will be there. Okay, so here very fast the growth is taking place, very fast, 2, 4, 8, 16, 32, 64, like this, very fast. So what happens? Initially the growth is slow, but after a particular period of time the growth rate will increase fast. Okay, or it extends fast. What happens here? Now here in a short period of time, say time is only this much and lot of growth had taken place here. So this phase is called as log phase, or it is called as exponential growth phase. Okay, now what happens after getting lot of division, many cells are formed, and one stage comes when all the cells becomes, or their growth becomes steady or stationary. So what happens here also, little bit cell division will take place, but maximum cells will become differentiated. So here little bit of growth will take place, or the cells becomes stationary, or the growth becomes stationary, cells becomes differentiated after a particular or long period of time. So here we get three type of growth: lag phase, log phase and stationary phase. Here three types of growth means growth at the first stage is very slow, at the second stage it is very fast, and at the last stage again it becomes steady or it is very slow. This geometric growth can be calculated with the help of one formula. This formula is nothing but W1 is equal to W0 ERT. Now it may be, W means it may be weight, it may be size, it may be length. Okay, so here we are considering weight, okay, or size. W1 means it is the final size of the plant. W1 means it is nothing but it is the final size. W0 means it is the initial size, whatever the size of the plant is here, initial size, or you can say initial length. Okay, W1 is the final size or final weight or final length. W0 is nothing but the initial size or initial length. And E means it is nothing but base of natural logarithm. It is always 2.7182. And where R means, this R is nothing but rate of growth, how much growth had taken place, and T means time interval, means how much time is required for the particular growth to take place. So here we have completed geometric growth. In geometric growth I have explained you with the help of example, with the help of graph and with the help of one formula. So here we have completed types of growth.